Hello, welcome to Pre-Cal Lecture 2.1b, where we're going to continue our lecture on solving linear equations. So section 2.1.3, we're going to be talking about solving linear equations with rationals. And from last section, just remember that a rational expression is a polynomial over a polynomial. So we'll start with one that doesn't look too much different from your homework from yesterday. So let's say we want to solve for x, and we have 3 over x plus 2 is equal to 5 over 2x minus 7. And we want to solve for x. So let's do it the long way first. We could multiply in order to try to clear out some of these fractions, both sides by x plus 2. All right, so we have an x plus 2 out front, and then we have 3 over x plus 2 is equal to 5 over 2x minus 7. Okay, the x plus 2's will cancel out as long as x does not equal negative 2. And then what you would have is 3 left on the left side. All you would have is a 3. And then on the right side, we have to multiply the 5 by x plus 2 over 2x minus 7. So next, let's multiply both sides. So we have this new equation, but it's equivalent to the old equation because we multiplied both sides by the same value. So let's multiply both sides by 2x minus 7. All right, so we'd have 2x minus 7 out front, multiplied by 3 is equal to 5 times x plus 2 over 2x minus 7. So this time the 2x minus 7 and 2x minus 7 on the right, they cancel out. And then the resulting equation would be 3 times 2x minus 7 is equal to 5 times x plus 2. So this gives the same result as cross multiplying. So now you know really where cross multiplying comes from. It's just a shortcut of this longer procedure. But all we really did there was cross multiply. I just broke it into multiple steps. So cross multiplying, if we have 3 over x plus 2 is equal to 5 over 2x minus 7. So we've already done this procedure quite a bit. We'll bring that x plus 2 up and multiply it by the 5. And then bring 2x minus 7 multiplied by the 3. And what you have is 3 times 2x minus 7 is equal to 5 times x plus 2. So this isn't really a hard equation to solve. Distribute the 3. We'd have 6x minus 21 is equal to 5x plus 10. All right, and if we were doing the domain restriction, I don't want to forget that. When we cross that out, we'd have x cannot equal 7/2. But if I don't ask for the domain restriction, you don't have to put it. All right, and then we're going to make that 5x negative, move it over to the left, and it would just be x, and add 21 to both sides, and you'd have x is equal to 31. All right, you could check that, but I can tell you it does check out. All right, let's go. Let's just start with the shortcuts right away. And let's do some examples. We are still within this 2.1.3 that are maybe a little more challenging, but really not too bad. So let's say we have, I'm going to leave a little space here, 3x, so leave a little space between the example and writing the problem, over x plus 4 is equal to 2 minus 12 over x plus 4. All right, we could multiply both sides. We want to clear the fraction. So clear the fraction by multiplying both sides by what? So by multiplying both sides by x plus 4. So we'll put an x plus 4 out front. Then the x plus 4 over x plus 4 cancels with this first term, just leaving 3x. Now you do have to multiply 2 by x plus 4. And then the x plus 4 over x plus 4 cancels on this last term, just leaving 12. So we'd have 3x is equal to 2x plus 8 minus 12. I'm going to move this 2x over here, make it negative. So that's going to be x, and then 8 minus 12, x is equal to negative 4. Now you may want to circle that, but this example was chosen for a reason. You circle that and move on. What is the denominator? If you put in negative 4 for x, what does it make the denominator? In two places here. All right. Makes the denominator equal to 0. So you do have to go back and look with your final answer. Is it legal, that x value? And the answer is no. There is no solution. All right, so there might be some in your homework that is like that with no solution. So just be careful, make sure that you check. All right, I think I have room for one more example in 2.1.3. Let's say we have negative 2 over x plus 5 over 6x is equal to negative 1. Now we need to pick, if we can, a singular value or term that would clear both fractions. So you might be thinking, well, how about x? Well, if I multiply both sides by x, it does clear this first one, but it would make this term into 5/6. That doesn't clear the fraction. What could I pick that would clear both fractions? Well, how about 6x? All right. Well, the x's still cancel in this first term. X over x cancels. 6 times negative 2 is negative 12. And then 6x over 6x cancels here. So that just leaves 5. And then 6x times negative 1 would be negative 6x. So negative 12 plus 5, that's negative 7 equals 6x, negative 6x. Divide both sides by negative 6, and you'd have 7 over 6 is equal to x. And if I just eyeball that and I plug 7 over 6 in, it doesn't make any denominator 0. All right, so that will work for us. All right, so pretty cool. Sometimes you have to put on your thinking cap to decide how to clear the fraction. All right, let's finish this lecture up with section 2.1.4. That's solving linear equations with restrictions. All right, so our example here would be 4x minus 3 over 2x is equal to 2x minus 4 over x minus 2. So yes, you could go ahead and cross multiply here, and but it kind of makes things nasty because you're going to end up with some x squared terms, and we're in the linear equation section, so we don't really want to end up with x squared terms yet. How about if we try to factor before? So what could we factor out of this out of the numerator on the right? How about we factor out a 2? And then you're left with x minus 2 over x minus 2. Now you can cross that out as long as x does not equal to 2. So just make a note, instead of cross multiplying, you always try to simplify first. It makes your life a whole lot easier if you can simplify, maybe factor something out. So now we have 4x minus 3 on the left over 2x. We can't really simplify that. Is just equal to 2. Okay, so we could multiply both sides now by 2x. That'll clear this left fraction, and you're left with 4x minus 3 is equal to 2x times 2, 4x. All right, if we subtract 4x from both sides, all right, we end up with negative 3 is equal to 0. So that is a false statement. So in this case, we have no solution. I gave you a couple of no solution examples in case you run across that. But you would want to do this. The no solution part has nothing to do with the technique of simplifying first. All right, so our last example of this lecture will be the fanciest. Where we end up having to kind of do the most work. So let's say we have 1 over 1 minus 2x plus 6x over 1 plus 2x is equal to 3. So, you know, sometimes you just have to multiply in order to clear the fraction by the two denominators multiplied together. That's really the only common multiple you can get. So let's multiply both sides by 1 minus 2x times 1 plus 2x. All right, so I'm going to rewrite the equation again. 1 over 1 minus 2x plus 6x over 1 plus 2x is equal to 3. Okay, so the 1 minus 2x and 1 minus 2x cancels here. So what you are left with is 1 plus 2x times 1. So I'm writing the 1 this time for illustrative purposes. And then for this second term, the 1 plus 2x over 1 plus 2x cancels, and you're left with the 6x times 1 minus 2x. And then finally, we have to multiply that 3 by both terms. 1 minus 2x times 1 plus 2x. Okay, so let's distribute 1 plus 2x plus 6x minus 12x squared is equal to 3 times. Now this is if we FOIL this out, the middle term's going to go away. So that'd be 3 times 1 is 1. And then minus 2x plus 2x, and then minus 4x squared. So I FOILed that out. Now let's distribute the 3. We're going to go ahead and combine like terms here. 1 plus 8x minus 12x squared is equal to 3 minus 12x squared. Well, this is fortuitous. Also because we are not in the squared section. We're still in linear. We're not dealing with curves yet. I've got a minus 12x squared on both sides, so those will cancel. Now, if 1 was minus, 1 was plus, they wouldn't cancel. So now I have 1 plus 8x is equal to 3. So 8x is equal to, subtract 1 from both sides, 2. And x is equal to 1/4. Eyeballing it, 1/4 doesn't make the denominator 0 anywhere. So that will work. So your homework is going to be worksheet 2.1b. There are 10 problems, 10 questions, and I'm going to give you a couple of hints. So, hint, for number 9, you want to factor x squared minus 4. And then your hint for number 10, try factoring w squared minus 3w minus 4. So what that will do, what factoring will do for you, is will help find the common denominator. Then you can do these operations, all right? But factoring first will help a great deal. All right, that does it for this lecture. You may find these problems a little more challenging, but hopefully not too bad. Maybe we go a little bit beyond what you did in Algebra 2. And I will talk to you on the next one.